Good day, ma'am. I am Paulo DeLeon, together with Rovic Sermonia, and we're going to develop a clustering model in rapid miner using our chosen dataset. So we already imported our dataset in data folder. So let's drag here and connect it to the result. So let's run. So our attributes here are age, marital, duration, and that bar dot rate, constant price, that IDX, Euribor 3M, and NR employed. So we want to segment or cluster our observations based on the types of marital, and that is consists of three, which is married, single, and divorced. So we will identify if the observations are belong to married, single, or divorced. So let's put a set rule only for marital. Then we will identify these particular observations if this belong to what type of marital. So let's have first the set rule. Let's go back to the design view. Set rule. So the attribute name is marital. The target role will be set to label. So let's run. So now we have one special attribute. So going back here in our design group, let's normalize to get the mean, variance, and the standard deviation. Let's search for normalize. Let's drag here. And here in attribute filter type, which is here. So we will set to all because we want to normalize all. And that all is our 6 attributes, which is the age, duration, and that bar, that rate, constant price, that IDX, Euribor, DeLeon, and then are employed. And the method we are going to use is the C transformation. So the C transformation computes our mean, variance, and the standard deviation to make our data normalize. So let's run. So we will notice our data now are transformed and observations now are transformed. So we already normalize the data. So this time, my partner Rovic Sermonia will explain the rest of the operators or models that we're going to use.
So after we use the normalized operator, let's try to use the clustering. Clustering is a concern with groupings together objects that are similar to each other and dissimilar to the objects belonging to the other clusters. Now, go to our operators panel and let's search for clustering. Here, let's use k-means, then drag it to the process, and let's change k into 3. Then let's hit run. Now you can see our data set is divided into 3 clusters. Cluster 0 has 190 items. Cluster 1 has 12 items, and cluster 2 has 299 items, with a total of 501. Now, if you want to check uh, what where are the dataset belongs to the clusters. Let's go to a folder view. Here we can see uh, the data that is separated by the folder. Let's try to click one data. So sometimes the system would not allow us to see. I don't know why. But then let's go back to the design. And after we use clustering operator, let's try to uh, use the performance operator. Performance. Performance. Let's use cluster distance performance. So cluster distance performance allows us to take the data decentroids clusters model and clustered set as input and evaluate the performance of the model based on the cluster centroids. Okay, let's let's change this connection. I think this is the right connection. Cluster to cluster and cluster to XP. Okay, I think it's okay. Let's hit run. Okay. Here we can see that the average within centroid distance. We got negative 0.7.66. In the cluster 0, we got negative 0.749. In the cluster 1, we got negative 2.613. And in cluster 2, we got negative 0.703. And lastly, we go to Davis Baldwin, which got negative 0.72, which got the lower score, which is good data set. So that is all for clustering, how to cluster our data set. We hope that we learn something for this representation. That's all. Thank you.